Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So if we imagine we've got the 25 metre pipe here, and we've got the 35 metre pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440, because we're told in the question that the perimeter is 440. So put our lines in, because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69, because they're the bottom 2 angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom 2 angles are equal. So they're the bottom 2 angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. So we're going to start by doing a multiplication grid. And we're multiplying the x minus 11, so x and minus 11, by the x minus 3, so x and then minus 3. So x times x is x squared, x times minus 11 is minus 11x, x times minus 3 is minus 3x, and minus 3 times minus 11 is positive 33 because two minuses make a plus. Put the terms together, and you'll notice here that we can simplify. So we've got two x terms, so we can collect the x terms, and that will give us x squared minus 14x plus 33. So our answer is x squared minus 14x plus 33. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount, so we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So the first thing we need to do is we need to solve the inequality. So I'm just going to write out again just so we've got a bit more space. And let's put our tram lines in. So first thing I'm going to do is get rid of that minus 2. So we're going to add 2 to all three sides. So that'd be 29, 6x, and then 57. Okay, the next thing we're going to do is we're going to divide by 6 all three sides, so we get x on its own. That's what solve means, just get x on its own. So that leaves us with a horrible number, 4.833 blah blah blah. X in the middle, and then we've got, I think, 9.5. Okay, now we're asked to find the integer values. Integers are just whole numbers. So we're thinking about what are the numbers between 4.833 blah 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 and 9.5. Well, it can equal 4.833, but actually it can't because we're looking for integer values, which are whole numbers. So the first whole number is 5, then 6, 7, 8, and then 9, because it's less than 9.5, not less than 9, but it can't be 10 because 10 is more than 9.5. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%, and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now, they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69, and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. The way you do this question is very, very similar to if it was 1/5 minus 1/6. You need to get the denominators to be the same, and then you add or subtract the tops. Well, be subtract in this instance. So 5 and 6, the lowest common multiple of 5 and 6 is 30. So I'm going to times the left hand side, top and bottom, by 6, and the right hand side, top and bottom, by 5. So times the top and bottom of the first one by 6, you get 6x over 30. Times the top and bottom of the second one by 5, you get 5x also over 30. And when you've got a common denominator, you just subtract the tops. So it will be x over 30. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. I'm going to start off by labelling this triangle. So we've got a big A, big B, big C, and the opposite ones are little a, little b, and little c. And we've got to figure out whether we're using the cosine rule, sine rule, or something else. We've got 3 lengths, and we're looking for an angle. So whenever we've got 3 lengths and an angle involved in the question, it's definitely going to be the cosine rule. And we've got to figure out which of the cosine rules we're using, because there's 2 variants, one when you're looking for a length and one when you're looking for an angle. And we're clearly here looking for an angle. So the cosine rule I'm going to use is cos A equals b squared plus c squared minus a squared over 2bc. And all that is, if you don't know what this formula is, it's just a rearranged variant of the a squared equals. So it's just rearranged, and it helps if you remember both of the formulas for the cosine rule. It does make things a bit easier. So we're going to write it again, but this time with all of the numbers and letters in that are in the question. So instead of b squared, we've got 9 squared plus, and then the c squared is 6 squared, minus the 4 squared over 2 times b, which is 9, times c, which is 6. And when you do that on the calculator, you get 0.935 blah blah blah, but that's what cos x equals. So if we try and solve that now, all we need to do to both sides is the inverse cos. So we're just going to do the inverse cos of 0.935 etc. that's on the calculator, and that gives us 20.741 blah blah blah, and it says it wants its 2 decimal places, so that's going to be 20.74. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%, so we're going to take away the 8.1%, and then when we do that we get 91.9%. Make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100, okay? And what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory. And it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realising is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360. Take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360 take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360 take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we're going to just quickly write out our sequence, so 9, 22, 41, 66, and 97. And we're going to find the differences of each of them. So that's going to be plus 13. Then we've got plus 19. So they're different already. We know that it's not a linear sequence. And that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth, and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66, and 97. Now, we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. So the first thing to do is we want to find the roots from the sketch that we've got. And the roots are just where the graph crosses the x-axis. So we can see it crosses it here at -8. Crosses it here at 3. Crosses it here at 5. Now, what is special about roots? Well, roots are where the graph equals 0. It's where y is 0. And the only way to get to 0 is, for looking at this, is if one of these brackets is 0. So we're going to say, okay, well, let's have a look at the first one, x plus a. Let's get that equal to 0. Oh, equal to 0. So we're going to put in the first root in there. We're going to say -8 plus a equals 0. Add 8 both sides. A must equal 8. So if a equals 8, then the whole thing will equal 0. That's the first root done. Go do the same with the next one. X plus b equals 0. And this time the root is 3. So it's going to be 3 plus b equals 0. Take away 3 both sides, and you get b is -3. Then we're looking at the last one, x plus c. Look at the last root, which is 5. Oh, we're going to get it equal to 0, and then it's going to be 5 plus c equals 0. And take away 5 both sides, you get -5. And so if a is 8, b is -3, and c is -5, it means that at -8, 3, and 5, it will equal 0, which is what it does in our graph. Now you might say, well, why does a have to equal 8? Why can't b equal 8? It can. These can be in any order. And so if I wrote these in the opposite order, -5, 8, and -3, for instance, it would still be correct. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.